Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. When configuring Ethernet networks, it is important to understand the use of straight-through and crossover cables. A straight-through cable connects devices of different types, such as a computer to a switch or a router to a modem. A crossover cable is used to connect devices of the same type, such as two computers or two switches. The difference lies in how the transmit and receive wire pairs are arranged. Most modern network interfaces support a feature called auto-negotiation, which includes Auto 1501 and Auto 1501X, allowing them to automatically adapt to either cable type. Because of this, crossover cables are now rarely needed in most new installations. Cabling installations must also comply with safety standards based on location. Cable jackets are rated based on their resistance to fire and the type of environment they are installed in. For general use, polyvinyl chloride or PVC is commonly used. However, PVC releases toxic smoke when burned. In air-handling spaces such as ducts or ceilings, plenum-rated cables are required. Plenum cable is made from materials that emit less toxic smoke and withstand higher temperatures. Riser-rated cable is designed for vertical runs between floors and offers fire protection without the full requirements of plenum. Technicians must always check local building codes to determine the correct fire rating. The quality of the cable used in an installation has a direct impact on network reliability. Low-cost cables that do not meet certified performance standards may appear functional, but often fail under real-world loads. Proper certification ensures that cables meet or exceed the performance levels defined for their category. Certification tools are used to test attenuation, near-end crosstalk, return loss, and other electrical characteristics. In professional installations, every cable run is certified to ensure consistent performance. Using uncertified or counterfeit cable may lead to unreliable connections, slower speeds, and difficult troubleshooting. Technicians rely on a standard set of tools to build and test Ethernet cables. A crimping tool is used to attach RJ45 connectors. A cable stripper safely removes the outer jacket to expose the inner conductors. A basic cable tester checks continuity and pinout. More advanced testers verify performance characteristics, such as signal loss and impedance. These tools ensure that the physical connection is built correctly and that the resulting link meets the desired performance level. Improper use of tools, or skipping testing altogether, increases the risk of cabling issues. One benefit of newer cable categories is backward compatibility. A Category 6 or Category 6A cable can be used in a network with older Category 5 or 5E devices. However, the network speed will only be as fast as the lowest rated component. This allows technicians to install higher performance cable in preparation for future upgrades. Even though the current devices may only support 100 or 1000 megabit speeds, the cabling infrastructure can support 10 gigabit in the future without rewiring. This planning is useful for long-term cost savings and minimal disruption. Shielding provides additional protection in environments with high electrical interference. Shielded twisted pair, or STP, uses a conductive layer such as foil or braid to block outside noise. This is useful in industrial settings or near sources of electromagnetic radiation. Shielding can be applied to each pair of wires or to the cable as a whole. However, shielding only works if the cable is properly grounded. Without grounding, the shield can act like an antenna and introduce more noise. All components in the cabling path, including jacks and patch panels, must also support shielded cable to be effective. Installation practices have a direct impact on signal quality and long-term reliability. One key factor is bend radius. Cables should not be bent more tightly than their rated minimum curve. Excessive bending can distort the internal twists and degrade signal performance. Pulling cables with too much force can damage the conductors or loosen the connectors. It is also important to avoid routing cables near sources of electromagnetic interference, such as fluorescent lights or electric motors. Proper cable management preserves signal quality and reduces the chance of failure. Patch cables and bulk cables serve different purposes in network installations. Patch cables are short, flexible, and typically pre-terminated with connectors. They are used to connect endpoints like computers or printers to wall jacks or to link patch panels to switches. Bulk cable, on the other hand, is used for permanent runs through walls, ceilings, or conduits. It is pulled and then terminated on-site using keystone jacks or patch panels. Bulk installations allow for exact cable lengths and more structured designs, while patch cords offer speed and flexibility during changes or repairs. Color coding and labeling are important practices for identifying and managing cables. Color-coded jackets can indicate the purpose of a cable, such as blue for data, red for voice, or yellow for security devices. Labeling both ends of each cable with matching identifiers helps technicians trace connections quickly during troubleshooting. In larger installations, structured cabling standards require consistent labeling, documentation, and sometimes even mapping. This reduces downtime, simplifies maintenance, and improves efficiency when adding or removing equipment. Understanding Ethernet cabling standards is an important part of the exam. Candidates must be able to distinguish between Category 5, 5E, 6, and 6A cables. This includes knowing their maximum supported speeds, typical use cases, and physical differences, such as insulation thickness or shielding. It also includes the ability to identify when a cable is appropriate based on installation environment, speed requirements, and compatibility with existing hardware. Questions on the exam may ask about cable choice, termination methods, troubleshooting connectivity issues, or identifying symptoms of signal degradation. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.